So in this practice, the growth of world population is described approximately by the following equation, differential equation. dn over dt is proportional to the number of the populations, n, and the proportional constant is k, where n is a world population, and k is a constant value. And the world populations was 6 billions and 3 billions in 2000 and the 1960s. The first question is predict the world population in 3200. So to solve this question, we need to solve the differential equations. So dn over dt equal kn. To solve this equation, we can collect all the n terms to the left-hand side, and the right-hand side is t. So dn over dt can be changed, n is and the dt is moving to the right. So dn over n is equal k dt. Then you could perform the integrals. So in this case, if you find some functions, the derivative of this function is 1 over n. What is the answer? Is a log functions, log n. And the right hand side is kt plus integration constant. Okay, then you can write n equal exponential kt plus c. Okay, you can write n sub 0 exponential kt. In this case, n sub 0 is equal to exponential c. So we have expressions for the n. World population is described n sub 0 exponential kt. Then we have two conditions. At t equal 2000, world populations n is 6 billions, 6 times 10 to 9. So this means 6 times 10 to 9 equal n sub 0 exponential 2000 k. T equal 1960s. World population is half, 3 billions. So this is 3 times 10 to 9 n sub 0 exponential 1960k. So this is the first equation and the second equation. If you consider the first equation over second equation, left hand side is quite easy. 2 is equal n sub 0 is cancelled out. So exponential 40k. So we have a exponential of 40k is a 2, and then you can remove the k. So original equations n equal n sub 0 exponential kt. So this is, you can change this exponential 40k times t over 40. This is a little bit tricky, so you can substitute it here. N sub 0 2 times 40 t over 40. Okay, then we can use the equation 1 to find n sub 0. 6 times 10 to 9 equal n sub 0 2 to 40, 2000. From these equations, we have n sub 0 equals 6 times 10 to 9 times 2 to minus 2000 over 40. And then we can substitute here. Then n is 6 times 10 to 9 times 2 to t minus 2000 over 40. So this is a general expression to find out the world populations in futures. So we use this expression to predict the world population in the futures. First one is 1200 years later from now on. So 3 to 0, 0. So you can substitute 6 times 10 to 9 times 2 to 1200 over 40. So this is times 2 to 30. So how can you discover this number 2 to 30? Maybe it might be a little bit difficult if you are not familiar with the numbers. But if you maybe you have an experience to find the number of the 2 to 10s, 2, 4, 8, 16 is nearly 1000. Then 2 to 30 is a 2 to 10, 3. This is about nearly 3, 3. So this is 10 to 9th. Then you can substitute these numbers here. So it's about 6 times 10 to 18th. This is about the populations in futures. So if you believe that this formula is a really good approximation to predict the numbers in recent years. Then second question. So second question, assuming the average mass of human being is 50 kilograms, find the total mass of humans. So total mass of the human is obtained 50 kilogram times number world populations. Then it becomes 3 times 10 to 20 kilograms. This is the total mass of the human beings in 3200. So 1200 years later from now. Then in the last practice, we estimate the mass of the oceans with 10 to 21 kilograms. Actually, mass of the human beings in the 1200 years later is 1/3 of the mass of the oceans. This cannot be possible. So maybe you understand. We have to reduce the world population is one of the most important issues. So this is the end of this practice.